And we together, although not alone, with a lot of other people at Rothamsted, have developed a new, well, it's certainly a large-scale experiment. It involves crop rotations and a few other things. So just a reminder, if you don't remember John, that's John on the left, and that's me on the right. So we have created a large experiment on 2 sites. This is the one in the further east in Suffolk, on the east side of England, on a farm called Broomsbarn, which is one of our research farms. And the soil type here is a sandy loam. So that's why we went out to that farm. And this is the experiment that's run slightly longer. This one was first sown in the autumn of 2017. And then this one is the version at Harpenden, slightly further west, just north of London. And this soil type is silty clay loam, so a bit heavier and a bit harder to work with, potentially more productive. And this one was first sown in 2018. There are several reasons why we started in different years, and now that we're actually working on them, I'm very pleased that we did, because to do some of the operations we do on not every year, on a cycle in the same year on both sites, would be a tremendous amount of work, which we probably couldn't really do to the best of our ability. So all those plots, those squares across the fields, they are set out to look at two high-level treatments. One is cultivations, and that involves either thorough soil disturbance. We call it inversion. It is a classic moldboard plough. The old way, you might say, but yeah, it's still very effective. And the other one is the opposite. So it's direct drill into stubble or previous crop residue with absolutely minimal soil disturbance. And then we have 3 crop rotations. So we have a very simple, on the sort of upper left, a very simple three-year rotation, which involves 2 crops of winter wheat and a crop of oilseed rape. It used to be really quite common on the arable farms of sort of eastern England and central England. It's becoming less common. It's lacking in diversity, and there are issues, there are problems that are starting to be seen quite plainly now. That said, we didn't put it into this experiment simply to let it fail because it's got problems. There are other research activities at Rothamsted which are looking to address some of those problems. So we're looking at this short rotation as a place to demonstrate some of our own work, and I will mention that in a moment. The second rotation, probably a little more representative of what most arable farms are doing now, and that is introducing some more break crops between the wheat crops, lengthening the rotation, more diversity. So we have a spring legume, and that is beans, faba beans, Piscia faba. We also have a spring cereal. So apart from diversifying the types of crop, we're moving to putting some spring sowing in, and that's actually quite important for several things, particularly weed control, but also, as I'll show in a moment, we're now putting in this rotation and the next one, we're now putting cover crops over winter in between harvest and sowing again in the spring. And we've also got the oilseed rape in there, which is still, well, despite the problems it has, is still quite common on the arable farms. And then we went for something really quite different. 7-year rotation, more diversity. This is based on a small number of farms where we've seen people making this work quite successfully. So now we're introducing a 2-year lay. In this diagram, it is grass clover lay, but we're now going to move to just 100% legume, 2-year sowing of a 100% legume mix. And this is where we introduce some difference. So in most things, the two sites, the two farms are the same, running the same experiment. However, on the sandy loam soil, it's very common to grow sugar beet. And actually, the Brooms Barn farm traditionally had a long history of sugar beet research. So we're putting sugar beet into the rotation there, but it really isn't a good crop to grow on the silty clay at Harpenden. So we've put linseed in place of the sugar beet. You'll also notice from there that we have an organic amendment going on. In the two longer rotations where you've got a spring crop coming, because it just gives you a little bit extra time to do that work. And in the that's actually in the wrong place. in the 3-year rotation, it actually comes after the oilseed rape crop. So again, you've got a little bit extra time with the early harvest of the oilseed rape to get that organic amendment onto the land before you plant that winter wheat. So yeah, some of those which we sort of call a second level of treatments. We've got the organic amendment. It's 30 tons per hectare of a compost. It's municipal and domestic garden waste, which is collected and composted at facilities. There are several around, into something quite useful. It's quite variable, obviously. The material it started with is very variable, but we've analysed it. It's got some useful nutrients in it, and of course it's a good source of carbon. Actually, it's correct on this slide. It goes between the oilseed rape and the winter wheat, and then between spring sown crops. An extra, completely separate level of treatment is this thing called smart crop protection. It was the title of a large program of work at Rothamsted until a few years ago. And as I said earlier, this is in some ways looking to address some of the problems that we've seen in the very short first rotation, the 3-year rotation. We've got things such as research that has shown that some wheats are what we call low take-all builders. So if you grow them as a first wheat, the following second wheat, if you're growing two wheat crops in a row, will generally be less affected by take-all following this variety of wheat. We've put things in like a 3-way blend of varieties to look at reduction in fungicides. So that's quite an old technique where mixing genetics can delay the progression of a disease through the crop. We've put companion cropping in for oilseed rape to try and deter cabbage stem flea beetle, which has become a very serious pest of oilseed rape, particularly with the loss of pesticides recently. The control of the beetle is now very difficult. So we're trying to deter it. Well, we were reducing the number of sprays, again, fungicides in the oilseed rape. And also for sugar beet, we've put in a companion crop to try and deter aphids, which is another similar story, particularly virus-carrying aphids and the removal of insecticides, which used to control them in the old days. It is fairly flexible. Things are considered. It's a systems approach. We can't change things. We don't want to make big scale changes because it is a long-term experiment and you need many years to get real results. But we do consider that it's got some flexibility, which is not the case with some of the older long-term experiments at Rothamsted, which are really very fixed, and you can't change treatments or management. So the cover crops, in the 5-year rotation, it's a very simple cover crop with Phacelia and black oat. In the 7-year rotation, it's much more complex. We've got 3 types of radish: Niger, bristle or black oat, and common vetch. Actually, there's a clover, there's 2 legumes, yeah. So that is the ryegrass and clover ley that we started with at the bottom here. But as I said, we are moving to putting in a 2-year legume mix now, which is actually supported under an environmental scheme that we now have in, well, we have in England, not in the whole UK. They're all different. So baseline measurements were made when we started, obviously, autumn of 17 at Brooms Barn, autumn of 18 at Harpenden. Here we have a couple of people collecting soils for looking at the soil microbiome. We looked at penetration resistance, cone penetration resistance on Brooms Barn. You can't actually do it very easily or very well at Harpenden because we have a high stone content. So you can't really get very good measurements of penetration resistance. And that's the soil corer taking cores for nutrition and carbon, etc. There was a sample for the weed seed bank. So that's on the left there, done by the germination method in trays in the glasshouse. That's the graph on the right is the penetration resistance at that point in 2017, just after the last harvest before the experiment. Not unusually, you've got quite a layer of resistance at about 40 centimeters depth. That's quite common in these sandy soils. And of course, it's just about at the limit of what you can take any action with conventional farm machinery. So that's a limitation. And of course, being a sandy loam, it can be quite susceptible to drought. So rooting and rooting depth is actually quite important on that side. So this is the initial carbon, and this is percent carbon. So it's not organic matter or anything like that. And well, quite fortunately, there were no differences between the treatments when we started, which probably expected. It was a uniformly managed field for several years before the experiment started. This is Brooms Barn, by the way. This is the sandy loam. So yeah, we can predict where we think it will go, and we've got measurements coming in now that will give us some new information as to what the first few years of these treatments has done. The weed seed bank, massive variation, but nothing that's actually statistically significant. The big thing is blackgrass, Alopectorus, which is a real problem on the silty clay, Harpenden, but virtually absent at Broomsbarn. So that is going to be a real issue, and to see how the treatments affect the blackgrass population will be very interesting. Again, people making predictions. Let's see when the results are all processed for the first few years as to where we're going, in which direction these seed banks are going. So the first yield, the first test crop, the winter wheat crops we call test crops. So where we've got a crop of winter wheat, which is common across all the rotations, of course, that's the one that we're looking to give us an indication of how the rotation or the cultivation are affecting productivity. So we did get an effect of zero till direct drill, whichever you choose to use, and that we know is due to oats. So the previous crop before the experiment started, and this is on both sides, was a crop of oats, and there were reasonably large losses at harvest. So the ploughing, of course, buried that seed, and it wasn't a big issue. In the zero till, we had a lot of volunteer oats, and I have to say they weren't controlled quickly enough. They had an effect. Worms. So this is all still baseline. So not much happening with the cultivations yet. Obviously, there are predictions as to where that might go, and I think we would all have our thoughts about the effect of those cultivations on worms. Interestingly, very early on from the first cover crops, we're seeing an effect of having a cover crop in place on increasing the worm population, the number of worms counted, and that's from a very short period of growing those cover crops. So there is a piece of work which is trying to get itself published. It's on its way, looking at the effect of some of the previous crops on the wheat yield. So we have along the bottom there, we have the rotation and the previous crop. And then we see the wheat yield either with ploughing or with zero till. Variable, very variable at the moment. Sometimes ploughing is quite a lot better. Sometimes zero till is a bit better. We're going to need, I think, many years of data to really get some strong ideas about how these treatments are working. And the weeds, as I said, about the blackgrass population, you can see zero till is allowing blackgrass to flourish. We have more seed in the seed bank, and it is having, there's plenty of variation there, but there is an effect on wheat yield, generally with less blackgrass seed in the seed bank, and from ploughing, we're getting a higher wheat yield as a general rule. Soil structure, another thing that we would expect our cultivation regimes to affect. Aggregate stability being one of our main sort of measures, indicators of what soil structure is doing. You can see some quite interesting results coming out now. This again is only from 3 years of applying the treatments. The interesting thing is, although we're getting better with our mean weight diameters on the right, we're still seeing lower yields from the zero till. And that's a number of factors, one of which is the oats in that first year of cropping with zero till. But we've had one or two issues with actually getting the drill to work properly, and not getting quite as good establishment as we would hope. So there are issues, and we have to work through these, and get these things to work to the best of our ability.